And this is on page 22 of your unit handout. Before we get started here, the one piece of advice I would give you is with combinations, don't overthink things. It's very easy to look at a problem and go, wow, that's pretty complicated. You want to try to keep your thought process simple. We're going to be solving problems involving combinations. Before we do that, we will have to review and talk more about the difference between a permutation and a combination. And then we will be using a formula for combinations, like we had a formula for permutations. We'll be using a formula for combinations to solve equations. So as a warm-up, I want everybody to think of having a group of 4 people, Alan, Betty, Charles, and Danny. And in case it's lost on you, that's A, B, C, D, to keep track of people in terms of letters. So my job is to select out of that group of 4 people, 3 of them, and one of them is going to be a president of a committee or group or whatever. One of them is going to be a vice president, and one is going to be a secretary. And then somebody else comes along and says, you know, I still want to look at this pool of people, Alan, Betty, Charles, and Danny, but I'd need 3 people to be judges in a talent contest. And the number of ways that I can select a president, vice president, and secretary from that pool of 4 people is different than the number of ways that you can select 3 judges from that pool. And I think it's obvious that it's a different number of options. But my question is, how is it different? How is the fact that we have president, vice president, and secretary different than saying we have 3 judges? There's got to be something we can say about this in words, that we're going to learn, basically, that the president, vice president, and secretary decision is a permutation, whereas the 3 judges is a combination. Craig?
The judges are all the same as each other?
The judges are all the same, true. So I want to pause here and make sure nobody misunderstands what you're saying to mean this is like yesterday's stuff where they're identical. We're not going to be dividing by, I mean, I guess we kind of are, but there's a different way to look at it. So they're identical, that's why it's a combination. What would you say about the president, vice president, and secretary? They're not identical. Is there another way we can say that? And you're bang on, that's right.
You're also picking for who's what there?
I'm picking for who's what there.
You pick Alan, Betty, and Charles. You're also picking that Alan could be president or
Right.
vice president.
So would you agree that president, vice president, and secretary are positions, whereas judges are not positions? They're just, you're a judge, you're a judge, you're a judge. They're identical, right? So I'm using this analogy because I can say these are positions, but the word position also means placement in line. Right? The word position, if I say, what's your position? Oh, I'm first, second, or third. So these are positions, so order is important. And order is not important because a judge is a judge is a judge. They're the same position. I don't even like using the word position there. They're the same role. This is the difference, everybody, between me saying I have these 4 people and I'm going to take 3 of them for ice cream. That's like me picking 3 judges. Or I have 3 gift cards, Earl's, BP, and Coliseum Steak and Pizza. And I'm going to give them to 3 of the 4 people. That would be the situation on the left. So, and this is what, between Craig and Alex, we've come to the conclusion of. ABC is different than BAC. Whereas for the judges, ABC is the same as BAC. They're all identical positions or identical roles. So when I take a look at kind of a color coding scheme here, the president is Alan in ABC. The vice president is Betty in ABC. And in ABC, the secretary is Charles. But in BAC, that's different. That's saying Betty is the president, Alan is the vice president, and secretary is Charles. And Danny wasn't picked at all in either of those 2 scenarios. Whereas if I go over here, A is a judge, B is a judge, C is a judge. There's no difference than me writing ABC and BAC. I have the same 3 people as judges. And again, in case it's not clear, what we're dealing with on the left is a permutation because the order is important. It may not be that you can wrap your head around an actual order of things. But I can in this case, that they have a meeting room where they meet, and there is a chair that the vice president sits in, and a chair that the president sits in, and a chair that the secretary sits in. Those chairs in particular physical locations, so there's an order to where they are seated. So how many ways can you select a president, vice president, and secretary? Well, it's 4P3. And I hope you graduated to that point where you're not necessarily saying, president, vice president, secretary, I'm going to use the fundamental counting principle. You can do it that way if you want, but it's 4P3. And can you confirm that 4P3, that the answer is 24? Okay. And just like the other day, this is for a different reason, I'm listing all 24 here. So I do want you to notice that the first line here, ABC, ACB, BAC, BCA, CAB, CBA, that's for president, vice president, and secretary. That first line is all Alan, Betty, and Charles. Danny is not anywhere to be found in the first line. Charles is nowhere to be found in the second. Betty is not in the third. And Alan is not in the first. So these are all of the 24 arrangements. Use the list above to determine how many different ways a group of 3 judges could be selected from the 4 individuals. Well, as I pointed out, these are all Alan, Betty, and Charles. I'm still looking at the president, vice president, and secretary. These are all Alan, Betty, and Danny, all Alan, Charles, and Danny, all Betty, Charles, and Danny. So if I change this, if you look at the screen, I change it to judge, judge, judge. There is 0 difference between any of those on the first row. They are all the same 3 judges. So I go from having 6 different items that involved Alan, Betty, and Charles to only 1. And the same thing could be said here. These are all the 3 judges being Alan, Betty, and Danny. These are all Alan, Charles, and Danny. And these are all Betty, Charles, and Danny. So we've gone from a whopping 24 arrangements, permutations of 3 items out of 4, to a lowly 4 combinations or groupings of 3 items out of 4. So the number of arrangements of 3 items out of a group of 4 is 24. The number of selections of 3 items out of a group of 4 is 4. What is it you do to the number of arrangements to get the number of combinations? In other words, why is it we went from 6 in the first row to only 1/6 of that? Or why is it we went from 24 in total to only 4? I mean, I can ask you what we did mathematically. You divided by 6. But why 6? Bashir?
So you take n and you divide it by r, so it was 4 factorial divided by 3 factorial?
Right, we have to divide by 3 factorial because the 3 items we're selecting, if I include the number of ways to arrange them, it's this big number, but there will be 3 factorial ways to arrange every group of 3. So I have to divide by that. And what I'm really telling you here, and I'm not shouting at you here, it's a factorial, right? When it comes up, it's like, geez, settle down, Mr. Way, I get it. You're dividing by 3 factorial. What I am getting at, and this is important the way you said it, is that it turns out that NPR divided by r factorial is going to give you NCR. Now, you didn't say that because you didn't know about this notation maybe, but I'm telling you the number of combinations can be found by taking the number of permutations and dividing by r factorial, where r is the number of items you were either arranging, if it's a permutation, or selecting. I like to use the word selecting here. for a combination. So when selecting, see there, selecting a group of items from a list and the order in which they are selected is not important, that's a combination. When there are specific positions, in other words, order is important, that's a permutation. And we've already kind of addressed this, but if this is the number of permutations, the warm-up shows that we have to divide that by r factorial, which means that this at the top of the screen here is the number of combinations. It's got that extra r factorial on the bottom compared to the number of permutations. So this is the formula for combinations. And it can also be written this way. So I need you to understand something here. It's very important in case you see it on an exam. If I say to you, what is this equal to? I'm asking you, how many ways can I select 4 items out of a group of 12? Not arrange them, select them. That's what a combination is. There is no special notation like this for permutations. When you see this, it's combinations. No argument at all. It's combinations, always. We still use rules of and or, and being multiplication, or being addition. So examples, in how many ways can 4 students be selected to go on a trip out of 15 students? Well, that's a real puzzler if you don't know anything about combinations and permutations and Math 30. You know, you're trying to figure that out? Don't. It's 15, choose 4. That's it. That's the answer to the question. And you can either write the answer this way. This is the answer. You can write the answer this way. You can calculate the answer using the formula, which says it will be 15 factorial over 15 minus 4 factorial, 4 factorial. Or you can calculate it by using your calculator. Right? You know where to go for the factorial and the NPR? Go to the same place for the NCR. By the way, if you want to do it using factorials, it's 15 factorial over 11 factorial, 4 factorial. But again, due to the placement of that factorial function in your calculator, it's a pain to get to. It's just as easy to go 15, math, choose 4. Turns out there's 1,365 ways to do it. What they all are is unimportant. Whether it's A, B, C, D, A, B, D, F, whatever. It's not important. Any questions with that first example? Thank you, kind sir. All right, let's try another one. On a student council, there are 8 females and 7 males, and we are going to create a committee out of that group of 15 people of 6 people. How many different committees are possible if there's no restrictions? Well, the answer would be 15, choose 6. And this is what I mean by not overthinking combinations. You have 15 items, you're going to choose 6. Turns out to be 5,005. There must be 3 females and 3 males. Again, don't overthink it. If you need 3 females on the committee, then you need to choose 3 females out of the 8 available. And you need to, out of the 7 males, choose 3. Don't overthink it. What do you need to? You need to pick 3 girls and 3 boys. How many ways can you pick the 3 girls? 8 choose 3. 3 boys, 7 choose 3. And I really wish we didn't have to delve into your calculator to find these functions. But we do. And I really wish it didn't look like that when you put it on the screen. That just doesn't look right. Are you getting 1960? There must be at least one male. Oh boy, that's tricky. That means you could have one male or two males or three males or four males or five males or six males, right? So, don't write this down. Could be one male and five females. Could be, right? That's at least one. Could be two males and four females. What does the word or mean? Add. Or, right? Or. So you have to ask yourself, if you want to do it this way, what you would have to do. One male and five female would be 7 choose 1 multiplied by 8 choose 5, because there are 7 males and 8 females, and you do 1 male and 5 females. Or means plus 7 choose 2 times 8 choose 4. I think you get my drift here, that this is not, well, maybe it is a little complicated. It's not conceptually difficult to follow this, but this is a whole bunch of work, isn't it? It turns out it's equal to 4977. If you do that, you get 4977. But we're not going to do it that way. We are going to use the same kind of thing that we've used before when, for example, I say, how many ways can the volleyball team members stand together if Joan and Emily are not together? We take the total number and subtract how many they are together. Well, if I say at least one male, there's only two possibilities. The committee has at least one male, or it has no males. That's it. So what is the total number of committees? And we do need to write this down. The total number of committees is 15 choose 6, which we worked out, didn't we? 5,005. How many committees with 0 males? So again, I'm thinking of that analogy where I write down all 5,005 committee lists on individual Post-it notes and I put them on the wall. And what I'm about to do is remove the ones that have no males, and I will be left with the ones that have at least one male. Before you calculate that, though, I want to point something out to you. I could have written that. Because I'm choosing 6 females and no males. And 7 choose 0 is 1. How many ways can I choose none of the guys? One way. I just don't do it. Anyway, this works out to, I believe, 28. So the reasoning here is the number of committees with some males would be the 5,005 minus 28, which will give you that answer. And I just want to throw something out your way, and I hope it doesn't just flutter to the ground. I hope it makes sense. If I said, so we're done with that question, how many committees have 2 or more males? Which means 2 or 3 or 4 or 5 or 6. I think you should still find the total number, but then you will subtract from the total the number with no males and subtract the number with 1 male, because that is quicker than finding those other 4. But I hope you see that as the number of males on the committees goes up, and I say at least 5 males, it's easier to do the ones with 5 and the ones with 6 and add them together than to subtract all the other ones. So there's some tipping point here where sometimes it's easier to just find the answer. Sometimes it's easier to find it by subtracting the opposite of the answer. Jimmy, the principal's son, must be on the committee. Why? Because there's favoritism in the school. I don't know. You can come up with your own scenario that makes sense to you. Well, in my mind, the answer is this. This is just me thinking. If Jimmy has to be on the committee, why even put him on the list? Let's just remove him from the list. We have 14 people on the list we're going to choose from, and we need to choose 5. If you want to separate this out into groups, you know, we had 8 female and 7 male, I think, yeah? Okay, well, I could say what we have is 1 Jimmy and 14 non-Jimmies, right? I could do that. So if I want Jimmy and 5 other people, then I need to choose out of the 1 Jimmy available, I need to choose that 1 Jimmy. And out of the 14 non-Jimmies, I need to choose 5 to complete my selection of 6. 1 choose 1 is 1. So in the time I've been talking, I'm assuming somebody has an answer. No? Kaylee? 2002. Don't try to read anything mystical into some of these numbers we get. They very often look like this. 5005, 2002, it doesn't matter. This is an important question in case it comes up on an exam, not this specific situation. Can you work out what 10 choose 3 is? Like work out, I mean, put it in your calculator. 120. Can you work out what 10 choose 7 is? 120, because I'm telling you they're equal. But my question is, why are they equal? And we can answer why they're equal by looking at the structure of the combinations formula, but that's not what I'm asking. I mean, you could say that for 10 choose 3, it's 10 factorial over 10 minus 3 factorial, 3 factorial. For 10 choose 7, it's 10 factorial over 10 minus 7 factorial, 3 factorial. You're going to get 10 factorial over 7 factorial and 3 factorial. That's not what I'm asking. I'm not asking why mathematically you get the same number. I'm saying why is choosing 3 people out of a group of 10 going to give you the same number of possibilities as choosing 7 people out of that same group of 10? Craig.
Picking 3 people is the same as picking 7 people to exclude.
Exactly right. If I say that everybody in this row, these 7 people, and everybody in this row, these other 3 people, they're the 10 people, and I'm going to choose 3 of you to go for ice cream. Okay? And I choose these 3 guys. How does anybody know that I didn't really say, geez, which 7 do I not want to take? I could have made that decision. And for when I choose a group of 3, I'm actually choosing to exclude the other 7. So if there are 120 ways I can select 3 people, there have to be 120 ways that I'm not selecting the other 7. Okay. But the key here, and I hope it wasn't lost on you, is 3 plus 7 gives you 10. Right? So if I said that 12 choose 4 is equal to 12 choose some other number that is not equal to 4, that other number is 8. Because if I choose 4 people for a particular event, I'm choosing not to choose the other 8. So I don't know what you want to write here. When you select a group of 3, there will be 7 in a group that's not selected. So you are selecting 3, but you are kind of choosing to exclude the other 7. And I like the word exclude. I've never used that before, but it's a good word. So for each unique group of 3, there's going to be a unique group of 7 left behind. But the key is that 7 and the 3 have to add together to give the total. If you choose not to decide, you still have made a choice. It's a lyric from Rush, by the way. This becomes important because you could be told the following on an exam. You might be given this situation on an exam, where you are given, it doesn't matter what the numbers are, 14 choose 6 equals 14 choose k minus 20. And you are told to find k, but you were also told that k is not 26. And this is all of a sudden elevated up to a more difficult question, right? So you're not allowed to say, oh, well, k has to be 26 because 26 minus 20 gives you 6. However, k minus 20 can also be 8, can't it? Because choosing 6 out of 14 is the same as choosing, is that right? 6 plus 8 is 14, I hope? Yeah. Choosing 6 out of 14 is the same as choosing 8 out of 14. So that means k is 28. You would obviously have to be told this nugget of information so that you couldn't just cheat and say, oh, it's 26. Any questions with example 3? All right, let's keep rolling here. There are 5 different toppings for an ice cream sundae, and you want 3 toppings. You're allowed 3. Because you're not crazy, one of them has to be chocolate, right? So what does this mean then? How many different sundaes could I choose from? Well, that means I'm really choosing 4 toppings, and I need 2. This is like Jimmy. I could say there is a chocolate and there are 4 others. And I need 3 total, but I want chocolate, so that's 1 choose 1. And I need 3 total, so of the 4 remaining, I need to choose 2. But I think there's nothing wrong with you logically saying, chocolate goes on immediately. And by the way, you can't have chocolate. It's not allowed. Chocolate goes on immediately, so the real question is, how many ways can you complete your order? How many ways can you choose 2 toppings out of 4? And this is 6, isn't it? 4 choose 2? Does anybody play crib? Does anybody who play crib, and it's very, very rare, know what 4 of a kind is, like 4 kings? 12. You know why? Because a pair is 2. And there are 6 pairs. Of these 4 cards, when you pair them off in groups of 2, there are 6 ways to do it. You can have the clubs and hearts, the clubs and diamonds, the clubs and spades, etc. There are 6 different pairs. That's why it's 12. It's also why 3 of a kind is 6, because there's 3 pairs, each worth 2. Don't need to know anything about crib, but I played crib for years and years before I realized why it was 12. I thought it was just some random number. In a classroom, each student shakes hands with every other student, and there are 300 handshakes. How many students are in the class? And this is algebraically determining it. Well, this means that 300 choose 2 has to be equal to, pardon me, this means that n choose 2 happens to be equal to 300. I misspoke and miswrote there. We're an unknown number of students in the class, and when you pair them off in pairs, that's what a handshake is, right? Every handshake is a pair of students. We get 300. Well, n choose 2 is n factorial over n minus 2 factorial, 2 factorial. How are you going to tackle that? What can we do here to clean this up? Jay?
Multiply the 2 factorial to 300.
Okay, so I can multiply the 2 factorial by the 300. Now what I have is, and we all know 2 factorial is 2, right? So 2 times 300 is 600. So now I have n factorial over n minus 2 factorial is equal to 600. Now what? Alex?
You could cancel the n minus 2 factorial from the n factorial.
We're back to factorial cancellation, that the smaller factorial, n minus 2, that's exactly right, Alex. N minus 2 is contained inside of n factorial. So we expand the larger factorial until we see the smaller factorial take shape. And I'm going to actually be overly ambitious here in writing this out. You could just stop at the n minus 2 and put n times n minus 2 times n minus 3 factorial. But this is over n minus 2 factorial. And n minus 2 factorial is this mess. So this is equal to 600. What are we left with? N times n minus 1 equals 600. This is easy. I mean, the factoring aspect is going to be a little clunky maybe because of the 600, but it's not. I'll show you some tricks around this. This is n squared minus n minus 600 equals 0. Now, here's a way to cheat the system. This is not a difficult thing to factor. It really isn't. You're looking for numbers that multiply to give negative 600 and add to give negative 1. So the two numbers are very close together. Personally, what I would do, and this may or may not make sense to some of you, and I can't remember if I've ever shown this to you, is I would say since the two numbers are very close together, I'm going to take the square root of 600 and just round up or down and see what happens. The square root of 600 is 24 point, well, maybe it's 25. Maybe it's 25 and 26. They're 1 apart. Yep, nope. Maybe it's 25 and 24. Yep. So they're 25 and 24. I'll show you another thing you can do here in a second. I need to have negative 1n, so that's the result. Factored correctly. Which means n is equal to 25, or n is equal to negative 24. That didn't make any sense. You're not going to have negative 24 students. So there are 25 students. The other thing you could do, well, two things. First of all, you were expected to algebraically do this up to choosing 3. So if I said that we had a group of students, elementary school students, and we're going to play a game where the teams are in groups of 3, how many different teams could I pick? You would do the same thing, but I hope you would see that you would cut things off here, and you would have a cubic polynomial to solve. But regardless of where you end up, you could just do this. Y equals x choose 2, go to your table and look for 300. Right? You can get the answer. Even if you're asked to do it algebraically, when I go to my table and I look for 300, it's happening at 25. So then when I get down here, I can go, oh, well, one of the factors must be n minus 25. Right? Nobody has to know what goes on behind the scenes. They're not in your head. All right. How many 4-letter arrangements are possible using any 2 letters from the word smile and any 2 letters from the word frog? So if I want to make a 4-letter arrangement using 2 letters from smile and 2 from frog, then I guess of the 5 letters in smile, I need to choose 2 of them. And of the 4 letters from the word frog, I need to choose 2 of them. And this will not give you the right answer, because there's something else I need to do.
Times 4 factorial over 2 factorial.
Almost. Just times 4 factorial. Once I have these 4 letters chosen, I also need to, so I need to go choose 2 out of smile and choose 2 out of frog and arrange the 4 items I've chosen. Can I ask why you said divided by 2 factorial?
I don't know, for some reason I thought some of the letters would be the same.
They're not. And I've made the mistake before of making up a question where some of the letters are the same. It's a nightmare to solve. If you have a letter in the word frog that's the same as a letter in the other one, dividing by 2 factorial doesn't work. Because it's not that you're guaranteed to have 2 identical items in your 4 letters. So we just multiply by 4 factorial. We could have also written this. Right, that's, I think 4p4 is overkill for arranging 4 items. It's 4 factorial. So does 5 choose 2, 10, by the way? I don't think it is, but I don't know why I said 10. I just want to know just what 5 choose 2 is. It is 10. Okay. I don't know what it is, 1240? No, I'm wrong. What does it work out to? Christy, do you have it?
144.
2440?
Oh no, 144.
Let me see.
Pieces.
Just 144? Did you
Oh,
multiply?
no, I didn't multiply. Hang on.
Yeah, let's multiply by the 4 factorial, or by the other one.
1440.
1440, when you multiply them all. So you're going 5 choose 2, which is 10, times 4 choose 2, which is 6, times this, which is 24, and you're saying it's 1440. Okay. How many diagonals are in a 12-sided regular polygon? Where did that come from? Like, just out of nowhere, we're talking about combinations, and I say diagonals. Well, if I draw a 12-sided polygon, and I can, it's very difficult for you to draw a regular 12-sided polygon. What is a diagonal? A diagonal is not a line at 45 degrees. That's not what a diagonal is. A diagonal of a shape, a geometric shape, is a line segment that connects vertices. But a diagonal must be inside of the figure. So the first thing to note, and I'm not going to draw all of these diagonals, is that these 3 lines happen to be diagonals. And each diagonal is arrived at by choosing 2 vertices, right? So if I said to you, how many ways can I select a pair of corners or vertices? The answer would be 12, choose 2. That's how many ways I can connect all of the 12 points. Why is that not the number of diagonals? Because that includes all of the sides. Can you tell me what 12 choose 2 is? Can we get a number on 12 choose 2?
66.
66? So there are 66 lines connecting these things, but this is one of the 66, this is one of the 66. All of these sides are part of the 66. I guess I already had that one. So I need to subtract 12. $66 minus 12 is 54. So the answer is 54. Now, it may be that, I could look at 5 diploma exams in a row and never see something with a diagonal question, but then on the 6th one there is. Permutations and combinations form about, I want to say, 10 to 11% of the diploma exam. Just thin veneer. But you never know which of the hundreds of different problems they might ask you. And finally, this is the last example, yes? It says that I have a regular polygon that has 119 diagonals. How many sides are there? Well, let's imagine this is a numerical response question. What this means is that the number of sides, choose 2, take away the number of sides, is 119. Right? The number of sides, choose 2, is how many ways you can pair up all of the corners or vertices. But each of the sides is not a diagonal, so we have to subtract that. So if this is a numerical response question, I mean, you could just pick a number for n. You could pick 14 and see if it works. I think it's more efficient to do this in your calculator. Again, I'm not a big fan of how it looks, but that's correct. And then go to your table, and we are looking for 119, and there it is, there are 17 sides. If this is a written response, and I'm not going to show you all of the algebra because we just did one similar to it, you would have n factorial. Well, you know what? I will take you just a couple of steps in. Over n minus 2 factorial minus n equals 119. I'm glad when I asked in the previous question about the handshakes, what would you do first, that Jay said multiply by the 2 factorial first. You don't have to, but I think it's wise here. When I multiply by 2 factorial, this becomes n factorial over n minus 2 factorial minus 2n equals 238. I have to remember to multiply every term by 2 factorial. I'll take you one step further, but I'm not going to solve it algebraically. This becomes that. I'll leave the rest to you. You expand it out, you simplify it, you factor it. Since n is a natural number, in other words, no decimals, it must be factorable. You'd have n squared minus 3n minus 238, and you'd factor it. Anyway, any questions with that final example? Okay, these questions are going to be varied. There's going to be a lot of variety here. I want to just address something with you first, though. We've looked at a problem where you have 8 empty seats on a bus, and let's say 5 people get on the bus. And because where they sit determines a unique situation, this is a permutation. Okay? But I've told you that this doesn't really make a lot of sense when you write 8p5, because 8p5 is thought of as meaning I'm going to get 5 people and arrange them. But you're not choosing 5 people, are you? You're choosing 5 seats. But you're arranging the people in the seats. To me, it doesn't make sense. You're not arranging 5 seats out of 8. You're not. You're arranging the people out of 5 seats. It's weird. It's confusing. So I don't do these problems this way. I say, if I want to find out how many ways they can be seated, then the first thing I do is I choose 5 seats that they're going to sit in, and then I multiply by 5 factorial to arrange the individuals. And you can go ahead and check that out. That will give you the same, because this is 8 factorial over 8 minus 5 factorial. This is 8 factorial over 8 minus 5 factorial, 5 factorial. So the 5 factorials cancel. I think it's easier to talk about filling seats by choosing the people first and then arranging the people. I'm going to leave it there. There was one other thing I wanted to show you, but I'm not going to right now. I might show you tomorrow. It has to do with a different way to do pathways. So get to work on these questions, please. A lot of different questions. Again, if you're not familiar with playing cards, then don't do questions with playing cards. I'm very, very saddened when I hand a deck of cards to a student and it's like I've handed them a nuclear device that they don't know what to do with. They've never played cards in their sad life. To me, that's sad. No offense if you're not a card person. Get to work, please.